Last lesson this week is on probability, and actually this is wrong. It's just lesson 70. I thought I could do 2 lessons, but I think I needed to camp out here instead of moving on. So probability is like, what is the probability of an event happening? And it's basically like the chances. If I say the probability of winning is 1 out of 2, 1 out of 3, that does not necessarily mean that every third one is a winner. It's just that the reduced ratio of winners to losers condenses all the way down to 1 over 3. Anyway, don't worry about necessarily what it means. It's kind of like the chances of something happening. We're going to talk about mathematically how to figure that out. All right, this first thing that you have written here is the actual formula to find this probability, and it actually is normally written. Let me write it down just like your textbook does. Let's see. Well, it doesn't matter. I don't even know where it was. Probability of something is the number of ways E can occur over the total number of possible outcomes. Yeah, that's a lot of words. Number 1, it's a fraction. You're going to have it in a fraction form, like a ratio. To find the probability, the top is the outcome you want. It is what you want over what you can get, and that'll make sense in a minute. So every textbook is going to give you this first equation. What you need to remember is, and what's easier for me, is what I want over what I can get. All right, and let's sort of look at how to use that information. Very often you're going to be given some information that you're going to need in order to solve these, and more often than not, these are word problems. So here's the information we're given. A card game has cards numbered 1 through 14 in each of 4 different colors: red, yellow, green, and black. So basically you have 1 through 14 red, 1 through 14 yellow, 1 through 14 green, 1 through 14 black. That's the set of information that we need to glean our information from. And we're asked, what is the probability of drawing a green card? So the equation is what I want over what I can get. Now, I want a green card. Well, how many different cards are there in this stack that are green? Well, I know that there's going to be 1 through 14, which is 14 cards, that can be green. Every other card in that deck will either be red, yellow, or black. 14 of them could be green. It doesn't matter what number I pull. I just want the probability of pulling a green card. So what I want is 14. Then over what I can get. Well, if I have 14 red plus 14 yellow plus 14 green plus 14 black, that means I have a total of 56 cards I could pull. I want a green one, and that's 14. So what I want is one of the 14 green cards. What I can pull is any of the 56. And then I need to reduce this down to the smallest form. Do not divide, because your answer must be a fraction. So if you're going to use your calculator, use the ABC or the fraction key. And when I reduce this down, I get 1/4. Now, some of you may have been able to get here without doing, may have been able to get to that fraction without doing all of the. I think that last problem glitched out, and I don't really know how to fix it at this moment, so we're just going to move on. All right, same set of information. A card game has cards numbers 1 through 14 in 4 different colors: red, yellow, green, and black. So here's the question. What is the probability of drawing a 7? Remember what we want over what I can draw. Now I can draw any card, right? So I can draw any of the 56 cards, but I only want a 7. I have a red 7, a yellow 7, a green 7, and a black 7, which means I have 4 different 7s in that deck of cards. Then I'm going to reduce that. I'm going to use my fraction key and not my decimal key. Nope, not my division key. And I typed that in wrong. 4 over 56, and it ends up to being 1 over 14. And that's the probability. Sometimes you're going to have to do a little bit of deeper thinking here. Okay, so a card game, same information. So what I want, oh, that's written messy, over what I can have. Well, I still can have any of those 56 cards. In this case, it says, what is the probability of drawing a card that is a multiple of 5? Now we got to kind of reach back into our brain here. What is a multiple of 5? 5, 10, 15, 20, 25, 30. Those are multiples of 5s. My cards are only numbered 1 through 14, which means I could pull a 5 or a 10. I have red, yellow, green, black. So I have 4 5s I could pull. I have 4 10s I could pull, which gives me a total of 8. Then I'm going to reduce it. 8 over 56 gives me 1 over 7. And that is my probability. So the can goes on the bottom. The want goes on the top. Sometimes you're going to have to do some thinking to figure out what the possible options are for what you want. And this is a little bit different thinking than algebra. So just do your best. So what happens when we are dealing with a coin? What is the probability of flipping a coin and getting heads? Well, that's not terribly difficult because remember, what we can get goes on the bottom. My coin only has 2 sides, a heads or a tail, which means I can get 2 different options, a head or a tail. I want heads. There's only 1 side of that coin with heads, so the probability is 1 out of 2, or 1/2. A lot of probability uses die. Later on, I'm going to give you a chart, not later in this lesson, but later at another date. I'm going to give you a chart if you're rolling 2 die, but for right now, we're going to talk about, or 2 dice. Right now, we're going to talk about rolling 1 die. Now, here's what you need to remember, and you know this. There are 6 faces on a dice, and they go 1, 2, on a die, 1, 2, 3, 4, 5, or 6. So the question is, what is the probability of rolling a 4 on a die? So what I want over what I could get. On a die, I can get any one of those 6 faces. There is only 1 4 on a regular die, which means I have a 1 out of 6 chance, or the probability is 1 out of 6. Now here's where that thinking process is going to come into play, and sometimes it's way easier than others. What is the probability of rolling a number less than 4? Okay, I can still roll any of those 6 faces. A number less than 6 could be 1, 2, or 3, which means I have 3 options to get a number less than 4. Once I reduce that, I get down to 1/2. So what you want over what you could get. Probability also uses decks of cards a lot, and they assume you know information about playing cards. I'm going to just reiterate this. If you have a standard deck of playing cards, you have 4 of every number, ace through king. That's 13 of every suit, so you have 13 hearts, you have 13 clubs, you have 13 spades, and 13 diamonds. I think I got them all. And then there are 26 red cards, because hearts and diamonds are red. You have 26 black cards, spades and clubs are black, okay? So this information that's in that parentheses there, that's not really given to you. They just assume you know that. So here's the question. What is the probability of pulling a red card from a standard deck of cards? Standard deck of cards has 52 cards in it. Red, there are 26 red. So 26 out of 52, because I could have any of those 26 out of the 52. When I reduce that, it goes down to 1/2. So I have a 1/2 of a chance to get a red card. Now, some of you could have been like, well, half the cards are red, half the cards are black. There's a 0.5% chance. So if you can get there like that, that's totally fine. Homework is another online quiz thing, and it should be linked right where you got this video, and that's it. What you want over what you could get.